Okay, writing equations of parallel lines. So first we need to identify what a parallel line is and what not. Parallel line are two lines that never intersect, and the key part of this here is that parallel lines have equal slopes, and that's the part that you have to know. The slopes of the parallel lines are equal, and that makes sense because if the rise over the run is the same for both lines, okay, then that means those lines are never going to get any closer to each other. Okay, now these two lines are not parallel, even though they don't touch here. All right, if we were to extend these lines, okay, you would notice that eventually, right, they would touch. Okay, so that's what makes them not parallel. Let's do a couple problems and see what this is going to look like. Write the linear equation for a line parallel to y equals 3x plus 8. Now look, the only important part here is this, the 3. That's it. That's the m value. That's the slope. Slopes are equal for parallel lines. That is the only necessary piece of information that we need. So if we're writing a linear equation of a line parallel, there's a million answers here. Y equals 3x minus 1. Y equals 3x plus 100. Y equals 3x. As long as that slope is the same in each equation, the lines are parallel. Example 2. So a little goofed up here. It's supposed to be a 1/2. Okay. All right, so example 2, now we're trying to write the equation for a line parallel to 1/2 x plus 3 and passes through the y-axis at 0, -5. So this one's a little bit more specific, okay? It's giving us, yes, a slope of 1/2. That's the only part we need from the equation. So we extract that slope, okay? So m is 1/2. Okay, now it's passing through the y-axis at 0, -5. So we have to get good at this, right? We have a slope. We have a y-intercept. So that means we use slope-intercept form. Those of you that have really caught on to this, I think are doing really well at this point. All right, those of you who haven't, again, keep trying. All right, you get oranges, you make orange juice. So y equals 1/2 x minus 5, slope-intercept form. Because we're given a slope, and we're given the y-intercept. Write the equation line that is parallel to y equals -4x plus 7 and passes through the point 2, 3. So here we go again. Parallel means same slope. So we're going to extract just the slope from that equation. We don't need any other piece. And it passes through the point 2, 3. Okay, so what is this? Point. What is this? Slope. Point, slope. Point, slope. Point, slope. Point, slope. Point, slope. Use point, slope form. Y minus y1, m, x minus x1. We use this because we have the slope and the point and the slope, the point and the slope. So in the point we have an x and a y value, and here we have the m value. We plug those in. Y minus 3 equals -4 x minus 2. The biggest thing here is the recognition of when to use slope-intercept, when to use point-slope. It's going to keep happening. It's going to keep coming about. So the sooner we get this, the better we'll be. Okay, so here we go. Write the equation for a line parallel to the one picture below that passes through the given point. All right, so to do a problem like this, we're going to first have to figure out the slope of the line that's given. So if I use the dots provided here, now last time I tried this, I could not see the units of the graph. I still cannot see them. I'm not sure why. So if I get this wrong from home, that's why. All right, so if I'm counting my blocks, my rise looks like 1, 2, 3, rise 3. And my run looks like 1, 2, 3, 4, okay? 2, 3, 4 blocks for run, okay? So my slope here would be 3 over 4, but my line is going down from left to right, so that's going to be a negative growth, okay? So to get the equation of this line over here, I have two options. I can use the point that's provided to me, which appears to be -2, -3. And I could just write point-slope form because I have a point and I have a slope. So if I did that, I would have y minus -3 equals m x minus -2. And I'm done already. Okay, probably for good measure, I would change these to pluses. And I wouldn't have to do any more. Okay, now if I want to use the graph to do this, I could just take my point here, execute the same slope. So up 3, okay, and left 4, right, and get another dot. And then I would draw my line, okay, with a ruler that goes through these 2 points. And then I would write the equation of that line. The only bad part about that is, like we've said before, like I've coached you before here, that if this y-intercept does not look like a whole number, then you better not be using slope-intercept form. We're not going to guess what that is. So no matter what in the end here, we end up using point-slope form to get our equation.